All right, finding a mathematical model. Ugh, I can't talk today. Anyway, mathematical model. So first off, basically fancy word for application or story problem. Here it comes. We're going to have a table that shows the mean, meaning average distance from the sun, which will be x, and the period. Now remember about periodicity? It's the time it takes a planet to go around the sun in this particular problem. We're not going around the circle like we did with our radians, but the period of time to go around the sun. Y for each of the 6 planets that are closest to the sun. So first off, we need to have a table with some astronomical units, and we're going to kind of compare it to Earth. We're going to let Earth be 1 because we consider a year to be 1 year. You know, 1 year on Mars is different than 1 year here on Earth. We're going to use Earth years. So, getting at the little Star Trek-y stuff. But here's what we know. Meaning this, the distance from the sun, if the Earth is 1 distance from the sun, then Mercury is 0.387, Venus is 0.723, Mars is 1.5, Jupiter 5.2, and Saturn 9.5. Mercury makes 1 revolution every 0.241 of our years. Venus does it in 0.6 of our years. Of course, we do it in a year. Mars takes almost 2 years, 1.8. Jupiter, man, if I lived on Jupiter, I'd only be 4 years old. Woohoo! So much for living on Jupiter, I'd only be 4. I guess I wouldn't be teaching math today then. But on Saturn, I'd only be 2. Well, I wouldn't even be 2 yet on Saturn. So it takes 29.4 years to make it for Saturn to go around the sun. All right? So we're going to take this information here, and this is given to you. They're going to have to give you stuff. We're going to write an equation for it. And we've been working with logarithms, correct? So let's kind of take a little bit of a hint here. And let's change the x and the y to natural log of x and natural log of y. Meaning, I'm going to take this number right here, take the natural log of 0.387 and natural log of 2.41, and you can see all those. And if I take the natural logs, this is what I get. And the reason these are negative is because they are less than 1. Because the only way you can get that is, remember, if your exponent's negative, because it'll be less than 1. And here, these are all positive because they're greater than 1. And these are 0, because remember, anything to the 0 power is always 1. All right? Now that we have these numbers, so it's a good hint, you're going to have to use some like natural log stuff maybe on a problem or two. So what we're going to say is this: I want to find the slope. And how do you find the slope? Remember, rise over run. And the y's are always on top of the x's. All right? And there's a way to remember that. Y is always on top of the x. Okay? So notice I have these nice color matches up. Y2, 0.6. Y1 is 0 there, the green 0. X2 is the 0.4, and X of 1 is that one. So plug them in, plug them in. Oh, I should have had the little doggy popped up. I didn't think of that till just now. I'm not going to go back and edit it though. And if I take those numbers and minus 0, that's kind of why I picked the Earth one, because it was easy. And I also picked Mars because all my numbers were positive. So here we go. It is close to 1.5, which as a fraction is 3 over 2. So my slope is 3 over 2, meaning y, the capital Y here, is equal to the capital X, 3 halves. If I take 3 halves, or 1.5 times the X value, I will get the Y value. So there I have my formula, but that's with the capital Y, capital X. Just put it in the natural log. So I put the natural log of those numbers in, it will work out. All right, I actually think those should be little y's. That should be a little y and a little x. Sorry about that. Those should be little y's and little x's. So, but that's the mathematical. There's a mathematical model of how we can use natural logs to help find a formula to help find these kind of information right here. You know, we talk about this, not rocket science. I guess it is. All right. So what have we learned today? We've learned about how to change bases, which you can do like the main number divided by the log of the base, or just use the alpha window feature. The alpha window, option 5, that's probably the best. So we've learned how to change those bases. We talked about the properties of logarithms. Mostly times are pluses, divides are minuses, and the exponents can move in front. We learned how to expand and condense logarithms, how we could use them to make them bigger or longer. Make us sound smarter by making them bigger. And making it sound smarter by making them condensed too. And then we learned about the mathematical model. Oh, I think I said it right that time. All right? And so we're going to practice when you come to class. Be ready. I'll be happy to answer questions. And most of this will be fairly quickly because your calculator will do some of this work very fast, and we'll be able to review for your test coming up. But page 203, 1 to 32, 45 to 54, and 67 to 76. And I hope that y'all have a great night.